When modeling, the objective is often to find a design with optimal performance, subject to constraints such as weight, cost, and spatial limitations. This can be achieved by running several simulations on different versions of a geometry. Whether it be adding, removing, or moving around the geometry in your model, your material, physics, and mesh boundary assignments need to be updated as well. This can be a cumbersome task, having to go into every node and reselect all the individual geometric entities that apply. Coordinate-based selections maintain your model setup despite these changes, by creating a list of geometric entities partially or completely enclosed in a ball, box, or cylinder. This is especially useful when an associative geometry is not available, for example, when importing the design from a file. We exemplify this issue with the shell and tube heat exchanger model, by changing the array of tubes and the length of the exchanger, and using these selections to easily update the model settings. So in this demonstration, we'll be using the geometry from the shell and tube heat exchanger tutorial model, which can be found in the application library, as well as a modified version of this. We'll be using this 3D component to define a cylinder selection, and then a 2D component to define a ball selection. The 2D geometry is a cross-section operation of the imported 3D geometry, so if we change this, it will also change our 2D component. And later on, we will change the geometry and see how the selections we defined handle these changes. In the first component, let's say we wanted to create a selection of just the tube walls inside of this heat exchanger. We could do so by creating a cylinder selection. We can add it by right-clicking the geometry node and going under selections and adding it there, or by going under the geometry tab, clicking the selections button and adding it here. So first off, let's change our axis type so it's in line with our geometry. And then up in the geometric entity level section, we choose the type of entities to include in the selection. Since we just want the walls, we'll choose boundary. Under input entities, this is where we can limit this selection to apply only to parts of the geometry. Right now it's set to the default option, all, or we can choose from selections to base this on other previously defined selections. Under size and shape, we enter the dimensions of the cylinder, and under position, we enter the coordinates of the center of the cylinder. And instead of entering numbers in all these fields, we can actually parameterize these values so that we could, for example, control the selection output by the parametric solver. I've actually already created a file for this, so I can go ahead and import that. And now I can just enter them in the respective fields for the cylinder selection. And keep in mind that your parameters can include numbers, other parameters, or even an expression. As I enter in the parameters, you'll notice a red outline popping up, showing the outline of the cylinder selection, and yellow shading showing the geometry that's included in it. Now under the output entity section, this is where we choose the condition for including entities in the selection. Entity intersect cylinder will in this case include any boundaries that intersect the cylinder. Entity inside cylinder requires the boundaries to be completely inside. And then we also have the remaining two options that require some or all vertices of a boundary to be inside the cylinder for inclusion in the selection. If we select entity inside cylinder, we are all set and we have created our cylinder selection. The baffles and other components are not included as they are outside of our defined cylinder. Now let's see how to use this selection. Selections are always available for all materials, physics, and mesh settings, and even for post-processing results. Here we will use the selection to apply a material, structural steel, to the tube walls. In the settings for the material, I can expand the selection drop-down list for more options, and choose the cylinder selection. Note that no clicking on boundaries is needed. Also, if we ever wanted to rename the selection so it more readily identifies the parts of the geometry it contains, we can do so. Let's say we want to call this tube walls, and those changes are reflected. In our second component, let's say we want a selection of only the small circular domains. A ball selection is perfect for doing this. So we'll leave the geometry level set to domain, the entities option set to all. Under ball center, we'd enter the coordinates for the center of the ball, which we want to leave at the origin, so that's fine. Under ball radius, we would specify the radius of the ball. And we can actually reuse our cylinder radius parameter right here, since it is a cross-section of the 3D component. So let's change our include entity if option to entity inside ball. And we're all set. Let's use this selection to assign a material, in this case water, to the small round domains. So we've finished defining our coordinate-based selections, but let's see what happens if we change the geometry. I'll import a different version of it, and now you can see it is longer than previously and that the tubes have a more sparse configuration. If I update the selection, we can see there are some boundaries missing from it. So this is where selections come in handy. Since I use parameters, it makes it really easy to update the selection just by changing a few of the values. So here I'll lengthen the selection. I'll change the center to start a little further, around negative 0.41 meters. And then I can adjust the top, making it longer as well. So 0.82. Click Build Selected, and with a few tweaks, our selection is restored. If we return to the ball selection, update the geometry, since our 3D component has changed, you can see that the selection is completely maintained along with the materials assigned to it. And this also goes for our 3D components material assignments as well, once we updated those parameters. Although I have not used it in this tutorial, the third type of coordinate-based selection, the box selection, works just as the ones I've shown. You can specify XYZ coordinates for the box limits, while all other settings are the same. So now you can see how coordinate-based selections are a type of smart selection available within the software. They account for changes made within the geometry and automatically update the selection wherever it is used in your model setup, so that any model equations, conditions, or constraints maintain their proper configuration in your simulation.